So today we're going to look at organic compounds. So firstly, let's look at the homologous series. So what's a homologous series? A homologous series is a family of organic compounds. So it's basically a family or a higher ranked a group. Well, like it contains hydrocarbons. It's a group of hydrocarbons with similar chemical properties. So how do they get the similar chemical properties? So there's something in common, which is a functional group. So first of all, a hydrocarbon is anything that contains carbon and hydrogen. So this is the hydrocarbon. So it contains a lot of hydrogen in it. So and we classified them into homologous series, into a family of organic compounds based on something special, which is a group of uh, elements or atoms, which makes it special. So firstly, we have the alkane. So for alkane, uh, the special type of thing that you need to have is that the functional thing you need to have is that you need to have a carbon-carbon single bond. So anything containing carbon-carbon single bond is an alkane. Not anything, a compound containing only single bonds, that's an alkane. So if you're going to name them, the suffix is going to end in "ane". So for example, ethane, so it ends in "ane". And the first part, the prefix, represents the number of carbon in it. So first, if you have one carbon, it's meth, and if you have two carbon, it's eth. For having two carbons, you have eth, and for the functional group, if having for you having only carbon bonds, you have only single bonds between carbon, you have alkane. So moving on to the next one is the alkene. That is you. So the special thing that alkene has is the CC double bond. So, so in a hydrocarbon, for that to be an alkene, you must have a double bond between two carbons, and that's going to make the whole thing alkene. So this whole thing is now going to become an alkene. At last, you're going to have ENE. So that's the functional group for alkene. And again, for having two carbons, you got the first part eth. So for one carbon, we have eth, we have meth. For second carbon of two carbon, we have eth, eth. So meth and eth. Moving on, and alkene has a general formula of CnH2n. And moving on to the other compounds, we have arene. These are actually uh, these are aromatic compounds, which are ring compounds basically. We're going to get into more details about this in A2, so we can skip this for now. So moving on, we have halogenoalkane. So halogenoalkane is basically an alkane, like uh, a hydrocarbon with C's. So instead of one H, what you have is uh, halogen. Halogen is an atom or is an element from the group 7. The group 7 is the Cl, Br, and iodine, bromine. So this the from group 7. So first you have the alkane part, which is the alkane chain. You have a single bond alkane, and instead of one H, you are substituted with one halogen. So the name suggests halogen. This is also called alkyl halide. So you have methane. You have one carbon, and the prefix chloro suggests a chlorine substituted. A chlorine has substituted one hydrogen. So moving on to alcohol. So for alcohol, what you need to have is you have a hydrocarbon and the functional group that defines it as alcohol, or the specialty or the special, what we name it as a functional group, that is the hydroxyl part, OH. This is the part that makes the whole hydrocarbon family of compounds, that is the alcohol. So for it having 1, 2, 3 carbons, we have propane, propan, and for it being an alcohol, we have all here. And the general formula goes like CnH2n plus 1 OH. Moving on to aldehydes. So aldehydes and ketones both are together are called as carbonyl compounds because they're quite similar. So the functional group of aldehyde is that it must have a CC double bond. So this is the functional group it must have. But one special thing, one other condition is that it must be on the end chain, on the end part of the chain. So it must be at the end. So the oxygen, the double bonded oxygen must be at the end of the chain, or at the last of the first carbon. So it must be at the end, always at the end. It must be here or here, never in between. So what happens if it is in the not in the end but in between two carbons? So that becomes a ketone, and their name goes like this. For aldehydes, you have aldehydes. So for here you have two carbons. For two carbons you have ethan, and for it being an aldehyde you have al. So it's ethanol. Moving on, for ketone, uh, you must have what I said is as a functional group is that it's similar to aldehyde, that you have a carbon bonded to double bonded to an oxygen atom, but the difference is that it must be in the middle of the chain. So one thing that is a minimum requirement is that uh, you always have three carbons. Like it's a minimum because it must be in the middle. For it being in the middle, you must have one carbon this side and the other carbon that side, right? So that is it for ketone. And moving on, we have carboxylic acid. So for carboxylic acid, we have two things. One is the carbon double bonded to an oxygen, and a hydroxyl compound bonded to carbon. So one carbon for carboxylic acid must be bonded to double bonded to one oxygen, and also an OH group attached to this. So this is the functional group of carboxylic acid. And moving on, we have ester. So ester is formed when carboxylic acid reacts with alcohol and forms an ester linkage. So this is also called an ester linkage. So what we have is this hydroxyl, this OH and another OH of the alcohol combines, and they lose H2O, and one O is left. So what you have is C double bonded to O, and again an O, and you have the other part, the C, and it continues. So whenever you see this thing, you can instantly say it's an ester, or in structural formula it can be written as COO. So moving on, so this is the part, and if you have a summary again, for alkane you need to have CC single bond. For alkene you have CC double bond. Alcohol you have to have OH. So you're right, we have a chain here, a hydrocarbon here. So for alkane you have single bonds only, and for having 1, 2, 3, 4 carbons you have the name but, and for being it being an alkane, ane, you get this ane part over here. Similarly for alkene you have ene here, and 1, 2, 3, 4, it's but because it has a double bond which makes it an alkene. For hydroxyl, for alcohol, we have a hydroxyl group attached. This part, this OH. So you have all here, and for it being, for it having 1, 2, 3 carbons, you have propane. So you have propanol. Moving on to aldehyde, for it being, for it is the functional group is must contain a double bonded O, but at the last carbon. Uh, so at the last carbon you have double bonded O, and this H is not a requirement, but it adds up into the formula of aldehyde because it must be at the last carbon, and the last carbon is usually, it's surrounded by hydrocarbons are surrounded by hydrogens. So, so this hydrogen is how hydrogen is there in the formula. But the main thing is that the carbon at the oxygen is double bonded to the carbon at the last or the first atom. I mean, in the end of the chains. So it's propan, and for being an aldehyde, it's al. Similarly, for ketone, it must be in the center, or it must be the carbon must be surrounded in the middle in such a way that you have carbon in both sides. So COO, and it's surrounded by carbons, or in other way you can say it's in the middle, not in the end. So it's on ketone, and for it having 1, 2, 3, 4, 5 carbons, you have the suffix pentane, and the 2 comes from the position of these functional group. It's the shortcut or the closest. It's from the you always count the lower carbon, like you can go in both ways, this way or that way. So it's 1, 2. You can also go like this 1, 2, 3, 4. But you always take the smaller number. So it's always take the lower number. So it's 1, 2. So it's 2. That way it's easier because the chain could be very long, and it's better to take the shortest, and that's how you take from the shortest way, shortest route. Uh, the shortest route to the functional group will is the way how you count the carbons. So moving on, we have carboxylic acid. As I said, two things. One is the C double bonded O and the OH part. So it's carboxylic acid, and the suffix for it is the oic, and you must also have acid with it. And for it having 1, 2, 3 carbons, you have propan. It's propanoic acid. For halogen alkane, it's just an alkane with an H substitute with an group 7 element or group 17 element. And you have the suffix bromo here, which means bromine. And you have 1, 2, 3, 4, so it's bute. And for it was an alkane before, so it is ANE. And similarly, you can have amine and also nitrile amide. So for amine, you need to have NH2, a functional group of NH2. So it is 1, 2, 3 carbons, so it is prop, and it is propylamine. And for ester, we have already seen that you must have a carbon double bonded to O, and again single bonded to O again, and there is another chain. So we will look into esters later when we talk about when we talk about carboxylic acid reacting with alcohol. And similarly, amide is you must have two things. One is the amine group, and another is carbon bond double bonded to O. So that's amide. There is De, and if you have that, you call it amide. I mean a suffix amide. So you have 1, 2, 3 carbons. It's prop, and for it having an amide functional group, it's for propanamide. So, but basically you need the only this few, like up to the halogen alkane. These are the ones you really need to know for the S level. The other ones are not that important. Moving on, now talking about the properties and how they react. Alkanes having only single bond and not having any other sort of atoms attached to it. It has no uh, uneven charge distribution, so it's non-polar, and the only forces, intermolecular forces acting in alkane is van der Waals forces. So it's just the electrons, the amount of electrons that's acting for the van der Waals forces. So for alkane it's the same. You just have only C double bond that doesn't make any great change, and it's also non-polar. And the bond it has, the intermolecular forces, or not the bond, the intermolecular forces between other alkanes is that it has only van der Waals forces. And the reactivity for both of them is low. But moving on to alcohol, what we have is a carbon is bonded to an OH. So we know that O is highly electronegative, and the carbon is not so electronegative. So the electronegativity difference between them, it's quite high. So it can have delta minus charge, and this can have delta positive charge. So the oxygen pulls electrons towards itself, and there is a unequal charge distribution, and it becomes a polar molecule. And for that, uh, the reactivity bit, or the the interaction between alcohol molecules can change. So the intermolecular forces they can have is hydrogen bonding, which is one of the highest, the strongest kind of intermolecular force that you can have. That is the uh, hydrogen bonding, and also for having polarity, the reactivity is quite high. Moving on to aldehydes and ketones, we know it's kind of same. It's double bonded to the oxygen atom, and the oxygen is also very electronegative, and the electronegativity difference is also kind of uh, great, and you get a polarity here, and for that the reactivity increases, but it's higher than this, but it's not uh, higher than the alcohol. It's lower than alcohol because the alcohol was bonded to OH. So this H is very lowly electronegative. Like the electronegativity difference between O and H is super high. So that makes it more reactive, and more the polarity between them increases a lot. The unequal distribution is more here. So that's what makes alcohol more reactive and more uh, reactive, right? And moving on, we have carboxylic acid. As the name suggests, this it acts like an acid. It's an organic acid. So compared to the inorganic acids like the H2SO4 and the other nitric acid and stuff, and the phosphoric acid, the reaction is similar. It acts very much like an acid, but the difference is that it's a weak acid, and for it having oxygens and other bonds, it is also polar, and it can do hydrogen bonding, and the reaction is high, quite compared to the alkane and alkenes and other, it's quite high. And the reaction is pretty similar to that of any acids, like acid plus metal. You know what happens. So that is the same kind of reaction you can undergo. Moving on to a halogenoalkane. So as I said earlier, that instead of an H, you are substituted with a group 7 molecule. So for instance, you have a Cl here. So we know that Cl is also very highly electronegative. Like the more you move towards the group 7, up the group or across the group, and you move towards the group 7 element, fluorine, the electronegativity increases. The electronegativity of the atom increases. So we know Cl is just right below fluorine, and the electronegativity of Cl is really high, and the electronegativity difference between them is also high. So it's also polar, and it has a stronger bond, However, it can have delta minus charge and delta plus charge, so the reactivity is a little higher than alkane and alkenes. However, the reaction, how do we do, like for instance, like if you have Cl, for instance, in a hydrocarbon or in a halogen alkene, uh, you might have a Cl or a Br. So how could you tell that which is more reactive? So in here, Br is more reactive because half the group, like it's more reactive. So Cl is more reactive, and when it reacts, it's more stable. But as it's more electronegative, the electronegative difference between them is high, and they're like more attracted toward each other, and the reaction, I mean, it's stable and they're stable. So, but Br, on the other hand, the electronegative difference between Br and C is less than the Cl and B, carbon and Cl. So what happens is you can easily lose Br, then you can easily lose Cl. So Br is more having a halogen alkene with Br is more reactive than having Cl, and losing iodine is more easier because the electronegativity difference between carbon and iodine is less. So the attraction is less, and you can easily lose iodine. So the highest reactive element in halogen alkene, the halogen, is if you have iodine attached to the alkane rather than a Cl. So this is the reactivity, like how it increases. Br is more reactive than Cl, and iodine is more reactive than Br. So for this class, this would be enough, and we will have to see you in the next video. Bye.